we're ready for our next talk, which will be delivered by Nokia's own Grzegorz Latuszek, and he will be talking to us about testing in the COVID-19 era. Grzegorz graduated from the AGH University of Science and Technology here in Kraków with a Master of Science thesis on building a software language compiler, and that included an analysis of language constructs used in a rare language called Oberon. Since then, analytical thinking about software has been close to his heart. During the 27 years of his professional career, he moved from CAD systems to the telecom industry, from C and C++ to Python, from being a software engineer to a Nokia Python trainer, where he is today. And he works in telecom tests automation, building Python libraries. Now, last time at TestDive, if you remember, he said wood handcrafting was his hobby, but since then he started a new hobby, which is blacksmithing. So he's made a DIY forge. It's like a workshop for metalwork, and he's already forged a few knives with his kids. But don't worry, no kids were harmed in this process, at least I hope not. So anyway, over to you, Grzegorz, testing in the COVID-19 era, but first do give us peace of mind and tell us about your safe kids.
No, yeah, kids are safe, as you can see. I'll just create something like this for my nephew. I'm still with the wood, so here's next root that I need to do something with this. Yeah, it has beautiful stone inside here. Oh, okay. I'm a little bit hard. Last my work with bass, so it was not so smooth, and I can do blacksmithing right now. However, I have still have left hand for keyboard, so I can code.
Okay.
So let's start. Okay, can you see it?
Yes, we can. Thank you.
Great. Okay. You may have noticed that we live in COVID era, haven't you? What I want to refer to in this talk is beginning of this time. The change related to our job was that we have been shifted to work from home. Luckily, in our profession, it is technically possible. And indeed, I know multiple people working part-time remotely, working this way even for years. I'm between them. But what was the difference? That all employees have been shifted to work from home full-time, whole the week. And you should remember that situation impact on our job. In simple words, overloaded network. Besides things like style-breaking video conferencing, poor voice quality, it has also touched more technical aspects of software development. My job is mainly focused on building Python libraries for test automation. Before COVID, I've done usual TDD development cycles like creating unit tests locally, creating production code locally, testing locally, and then pushing it into the GitLab server, and this triggered CI build on the Compiler Lab. And at COVID time, my tests started to fail more frequently than before, mainly because of different timeouts, not fitting in timeout limits. And after troubleshooting, I realized that root cause was an overloaded network. I didn't want to spend so much time on debugging environmental issues. I wanted to focus on code development. So I said to myself, what shall I do? As we all are engineers, we face such situations frequently, and inside testers community, even more frequently. What situations? Facing obstacles. And we are known for fighting against them. You know, all those workarounds, temporary code, fixing hardware bugs in software, and so on. So I started to think, what was my real problem? What is the root cause of this problem? And after the thinking, yes, it is network shared with others. How wonderful would it be if whole network was only for me? But hey, it is possible. I can create network that I need fully on my laptop. And this technique is known as virtual machines. Virtualization, containers, DevOps are buzzwords of new days. I knew it since I've been using it a bit in the form of single virtual machine. My first attempts were related to manual creation of such a single virtual machine. It worked, it was good for me. However, it failed from time to time, and then I need to create it once more, repeat the same steps once again, and stupid work. So I switched to Vagrant. It allowed me to automate building that machine. And more importantly, that automation was in terms of scripts kept under source control. This allows for improvements in building such development environment. Anyway, I had basic experience to start building something bigger. I started to learn Vagrant, learn VirtualBox, Linux, networking. I knew more or less in each of those topics. However, I needed more. So Googling, Stack Overflow, reference materials, different tutorials, and so on. And most importantly, experimenting. Does it work for me? You know, we have overwhelming amount of knowledge on the internet, but some are outdated, some not applicable, and some just false. You need to check it, test it. Aren't we testers here? Important thing to do this learning in baby steps and write down, record each of those steps, even misleading ones, for your memory. And I've done it using Git. Each commit was a next bit of building new skills. That way, I was able to create small network of Linux machines simulating LTE network elements. Since goal of my Python library at the time was to allow testing traffic over the LTE network from the UE side towards some servers inside the cloud. So under the hood, it was just simple jumping between different network boxes, being like some Linux machines using SSH and ADB, and firing IPA server and client on both sides, parsing the output, validating the output. That's it. So I have built this network using virtual machines under Oracle VirtualBox. And having that small virtual network, I was able to develop my library and test it not only on the unit test level, but also on integration test level. However, that's not the end of the story, because I was able to do integration tests locally, but not on the GitLab CI system. I realized that that my target development environment should have three characteristics. Be easy to recreate, so Vagrant. Be developed in incremental way under source control, so Git. And be same at home network and in corporate lab network. Third point was missing. Moreover, so I was able to do it around this integration. However, the size of all those virtual machines was like 20 gigabytes on my laptop. Nothing surprising. You have here 6 full Linux operating systems sitting on my laptop. And whole this process was long, around 1 hour to recreate full test environment. So I turned to Docker containers. I knew from the buzz around me that they are lighter in terms of space required, time to create, and that there are an important thing, that there are Docker runners possible on the GitLab. So having my network Dockerized would allow me to run same integration tests on laptop and inside the corporate lab environment. Okay, so I started to learn once more, bit by bit. And first, I have played with Docker Provisioner on Vagrant. It's good for beginning. It simplifies things for you by installing Docker on the virtual machine and speaking with Docker server in your name. From this time, I remember important thing, lessons learned that I want to share with you. Watch out on proxies. They are main factor why something is not working as you may have expected. You need to know when you are outside VPN or when you are behind the corporate proxy. You need to know IP or host name of corporate proxy servers, and they may differ depending on which site you are. So you need to be careful on which machine you run your stuff. And each tool may and have configuration file in different format where this proxy settings are stored. And because of those proxy issues, I was really frequently stuck.
No one wants you when you lose. Don't give up, 'cause you have friends.
Yes. Fortunately, I remember this Peter Gabriel song. Don't give up, 'cause you have friends. And I called my friends, my colleagues from work, and they shared with me proxy tips they knew, and they unblocked me. Ironically, after solving all those proxy settings, proxy issues, configurations, I found that there is even simpler solution, which is Vagrant ProxyConf plugin. It simplifies majority of your proxy configuration for different tools in your name. So go ahead and find it if you want to use Vagrant. But main issue with a Vagrant Docker provisioner is Vagrant. First thing, it has limited functionality comparing to raw Docker commands, but more importantly, I need Vagrant to run it. I didn't want to be Vagrant fixed. I wanted to run same stuff on Vagrant and on a GitLab. So common denominator here is bash. I switched to Vagrant shell provisioner and shell runner on the GitLab side. That allowed me to run any Docker command I wish. And having Docker commands wrapped inside bash script allowed me to have finally same development environment at home and in corporate lab. My common recipe looked like, first I need to build, of course, this Docker host machine, which at the corporate lab was a GitLab runner machine, some Linux bugs from cloud configured with the Python Git and the Docker, and similar software configuration, tooling configuration at local site made inside the or a virtual box with usage of the Vagrant. And having this, I built a Docker image with networking tools that were required for my integration tests, like SSH, ping, hyperv. Exactly two images. First was based on Alpine Linux, and the second was based on Debian with Python container. And on top of this point-free container, I have added another layer with a Python, pre-installed Python generic libraries that were dependency for my tests. And then another layer on top of this with Python libraries that were Nokia specific, Nokia internal libraries that were also my dependency. And these 3 points built test line image used later on for running, for building test line container, running my tests. And I have split it this way that up to 0.4, I was able to do it without touching network, corporate network, without going with the VPN, because all they touched was just open source packages for Debian and for Python. So I saved some bandwidth. And next point was replicating Git repositories with libraries and tests that I developed to later run them on, replicating into the Docker host, and later on they have been mounted into the test line container. I also had a need to use Docker to build additional network because my tests use static IP addressing, and I didn't want to modify a test, rather modify a testing environment to fit for testing needs. And then having all of this, I've just run these containers simulating UEPC UEs, application servers, and then running test line container, having all of this network tooling and Python libraries required for my test, and then I was able to run tests inside that test line container. This part is behind the proxy. I wanted to show you in reality how it looks like. However, for the needs of this conference, we are outside the corporate network, so we can't reach the GitLab server. However, I have downloaded this HTML files of a GitLab. I have it here. Let me show you. So this is usual view of GitLab pipelines. And here is this Docker-based pipeline that I have built. So these 5 first stages are just building testing environment required for my tests. First is checking just the Docker host. Then next is building this Docker network 3344 and pulling Docker images that have been prepared on the Vagrant side. And here on the CI side, they are just used. And then starting this Docker containers, first is this small network of Docker containers, and then this container being a testing test line. And then I run it. If we jump into the beginning of this process, I wanted to know how long will it take, hold the process. So I use uptime here and just taking the part of it. So we can see here that this machine is up for 23 hours and 30 minutes. Important is this 14 minutes. And if we jump to the end of this process where this tests are run, so it is like 15 minutes. Hold the process of establishing environment for my test is like a minute. Of course, this minute is because here at the stage of pulling Docker images, they are already on this machine. They have been cached. So there is no pulling, just checking if those are the latest images, latest version. If that was for the first time, this time of preparing environment was like up to 20 minutes, I would say. Okay. We can jump now to the local environment. We can even run it. It is also a quick process. Of course, part of this won't work because we can't reach a Nokia GitLab server, and I have created here some small script in Ruby to detect if I'm behind the proxy or outside. Here outside, the VPN is inactive, so I won't clone the Git repositories. Here you can see this proxy plugin running for me. So it configures proxies for apt, Docker, and Git for me. Then I do some cleanup of Unix new lines endings because without this some bash scripts failed for me. Then there is a configuring of Git access credentials. I populate machine with them. However, I can't reach GitLab server. So there is this yellow warning. The same with this replicating Git repositories. However, they have been cloned in previous run of the script, so they are present on the machine. The same is with Docker network. There is a check if they already exist. If so, if they are not created, then there is a creation of ADB simulator, creating SSH keys for this simulator. And then we have this starting with containers, simulating UPC, UE, UE2, application server 1, application server 2. Of course, they are also cached here. You don't see pulling them from the Docker Hub. So it saves a little bit of the time, this caching. Then there is verification if those containers boot up correctly, displaying their IPs. Those IPs are used inside my integration tests. Then once more, there's configuring proxies and starting test line container. Some cleanup for robot testing for the previous versions. They require Pybot instead of robot. And now we are starting the tests here locally. Okay. In the meantime, let's look how it is coded. Okay, so the real difference is only on the top layer. Here for local environment, I use Vagrant, so I need to create Vagrant file, which is a Ruby code, but in reality, it's just a kind of copy-paste format. You can see here is a shell provisioner that runs just a few bash scripts. This part is specific to local environment because on the GitLab side, GitLab is cloning Git repositories for me, so this is not required on the remote side. But later on, you have this scripts of creating Docker network, running testing net containers, and here running test line container. So we have this simple scripts of creating network 33, 44 for test, then running those containers of UE's application servers, and then running test line container. And the final step, running test, which is just simple Docker exec command, which executes my tests inside test line container. And if we look at the remote side, it is very similar, however, wrapped in YAML file, which is a format for GitLab CI. Inside those steps, which are called jobs in GitLab terminology, you see similar things here, running Docker status, pulling images, and here is the same firing bash script at Docker network, exactly the same bash scripts here running testing net containers, here running testing containers, exactly the same scripts running test line, and here final step is just this single command, Docker execute inside this folder, my script inside this test line container. Okay, let's go back to the console, and you can see that this is like 4.5 minutes local time for all this process of building environment and testing. It was 2 minutes on the GitLab side. So let's come back to the presentation. Okay, so benefit of switching to Docker is obvious that I have decreased the required size of my disk from 20 gigabytes to around 800 megabytes, and decreased the time required to create my testing environment from almost an hour to minutes. However, there is a drawback of a solution because I'm firing directly Docker commands on the Docker host machine. And on my local site is my local virtual machine. So who cares? I'm using this machine. However, on the remote side, this GitLab runner might be shared. Fortunately, right now it's not shared. It's my dedicated machine, so I can play with it. However, for the target solution, I'm fixed to this machine because I need to be careful in cleaning up those effects of those Docker commands on this machine. However, this is a normal behavior of a testing, that you do some setup, then run test, and you clean up after your tests. However, there is a more dangerous, another drawback that if we will have multiple testers running their tests on the same machine, so then those Docker commands modifying Docker host machine may interfere each other. For example, they may create the same named Docker containers, or trying to create same Docker network. So the test might fail because of this interference. So means that this is not the final solution I would like to have. Rather, it should look like this. Docker in Docker means I have nested containers. Inside this wrapper, big container, I could create the whole network that is required for my integration tests. And then modifications of building networks, building containers, any command is inside this wrapper Docker, so nobody else is touched, because this container is dedicated for me and I could be portable. However, this solution also has a drawbacks, because running Docker in Docker requires to configure a Docker service with privileged flag. So it sacrifices security for functionality of this nesting containers. But luckily, there is something even better, which is called Sysbox. It allows for nested containers without sacrificing security. However, it needs some functionality that exists in newest Linux kernel that right now are available only in Ubuntu. And I work with Debian images, so I have next obstacle at my face. Sorry, I should say next opportunity to overcome my limits.
Don't give up, 'cause you have friends.
Fine. I've told you my story and what is the net result of it. Net result for me, my personal benefit from this fight, from this learning path. COVID forced us towards home offices. We have lost our social environment. But think positively. We have exchanged our corporate cubics into something much closer to our hearts. We can work from much nicer nature, landscapes, environments, layouts. It can be even better. Okay, maybe those are not real layouts for teleworking. I think those images were made just for internet fun. However, those are real possibilities. And they are possible because anyone can have whole development environment on his laptop, thanks to this container technology. And also walking from such a beautiful landscape environment gives it another effect. You have probably heard the term clean code. Clean code is about making a code beautiful. How will you do it without feeling what beauty is? I believe that beauty around us helps in making beauty inside our code. That what might be your personal takeaway from my talk? Don't give up. Change obstacles into opportunity. Keep learning. Maybe one final note about learning in software engineering. Software engineering is a special domain in a way you learn. You may claim that you have learned something by reading articles, watching video tutorials, making online courses. But that's not true for programming. You know those books titled Learn C++ in 7 days or similar, okay? They lie. You can't learn programming without pain of programming by yourself, by your fingers. You need time, you need failures and obstacles to fight against. You need to feel pain and frustration and then joy. Yeah, at least it works. It really works. The same was with me as it comes to virtualization and Docker buzzwords. Till I started to use them, code with them, they were just buzzwords for me. Only during learning by my fingers, I understood that Docker containers are nothing more than just squeezed Linux operating system. And it is not so portable as it is claimed on marketing slides. Containers made for Linux won't work smoothly on Windows. Those built on top of Debian may not run Alpine Linux commands and so on. That's a kind of knowledge you get from experience only. You need to run it and test it and fight with it. How can you take this personal profit and extend it to corporate profit or even industrial profit? Share your knowledge, as I do right now. Do learning sessions with your coworkers. Share containers you produce in a way that others may benefit from it. And remember, don't give up because you have friends. Thank you.
Thank you so much. This is a wonderful message to finish with. Don't give up because you have friends, as advertised by Peter Gabriel and Kate Bush, 1986, I believe it was.
Something like this, yeah.
But it still applies today. Grzegorz, thank you so much for your talk, for sharing your wonderful experiences in how you've been doing it. You were just showing us before some sweet photos of yourself, you know, testing or programming or whatever you were doing in a garden with a tree stump.
In my garden. That was a wonderful weather. I was forced to go outside. My wife forced me to go outside from this room to be in nature, to get some sun, as it is today.
That's why I understand one person in our audience wanted to ask this question. Maybe you can tell us about, what were the most extreme or interesting conditions you worked under during this pandemic?
Extreme conditions.
Like, I don't know, in the rain, for example, hail, frost, at night, no electricity.
Not this way. Just when I went outside, I've just tried to do different layouts from the wood to put my laptop some upstairs. I have also, it also forced me to do my wood hobby, and I like it. Yeah. That's it. But, coding in the garden, yes.
Coding in the garden, why not? Sounds great. Grzegorz, thank you so much for your talk. This was Grzegorz Latuszek joining us and talking about testing in the COVID-19